Great. So, yep, as Kelsey mentioned, my name is Pooja and I lead product for the Filecoin Project. And today I wanted to kind of give a bit of a primer and some inspiration for why I think decentralized storage is so important and really is the storage foundation as we think about storing humanity's most important and valuable information going forward. And so this talk, I tried to structure it in 4 sections. The first was, why is decentralized storage interesting and important? How do decentralized storage networks generally work? Again, this one is pretty high level, but happy to dive into any of the details. How would you build with decentralized storage networks, and what are some of the use cases and applications that we've started seeing in the space that are really exciting? And then the 4th section is just sort of some inspiration for, the space is super young. There are a lot of opportunities to participate and jump in. It really is just the beginning. So what are some things that we're sort of seeing right now? I'm sort of seeing from the vantage point that I have that I think would be amazing if people in the world were to take an interest in and start building. So just some inspiration to get the creative juices flowing towards the end. All right, so first, why is decentralized storage interesting and important? So I really like to think of this taking a very large step back and just looking at this global trend, which is that the global data sphere is growing at an insane rate. And some projections tell us that it's something like in the next 4 years, the amount of data that we will have as a society will have increased at least in triplicate. Could be even more than that. It's obviously hard to project these things, but I think it'll come as no surprise to anyone that the amount of data that we're generating as a society is just increasing at an increasingly rapid pace. So it really is accelerating. But what's kind of interesting is that we're generating all of this data, but the vast majority of it today is actually not stored. And that could be for many different reasons. Often it's just like sensor data or telemetry data or whatever that's kind of like generated here and there. But today it's something like only less than 10% of all of the data that we generate as a society is actually retained and preserved. Another reality about the way that sort of storage looks today, and I saw that we have Avinash here from the Azure team, so repping Azure on the slide here. But obviously today the landscape of cloud storage especially looks like dominated by 3 major organizations that kind of capture most of the storage space. But meanwhile, there is something like more than half of the world's available data capacity sits unused in data centers just around the world. So that's something like, we have this global trend of the amount of data that we're generating as a society is just increasing so rapidly. There is a huge amount of data, just storage capacity available in the world. And yet we sort of are in this situation where we have a few major organizations that are the centralized cloud providers that are capturing most of the data that is actually the new data that's just sort of being generated and stored in the world. And so the question that we sort of think about when in the decentralized storage space is, does it really have to look like this? There clearly is a huge amount of available capacity that is waiting to be filled with all of this really interesting and useful information that is being generated every day. And the landscape could look a lot more diverse with, instead of just, a few very large players in this space, and maybe a few medium-sized players and a few smaller players, just hundreds or thousands of medium-sized players, and even up to millions or maybe one day even billions of smaller players who are providing this available storage capacity that exists in the world for a useful purpose, which is to store this massive amount of data that we're generating. And so this is really, I think one of the core inspirations behind a lot of the decentralized storage efforts that we have seen crop up over the last few years. So it really is just, instead of a few big players dominating our digital future, why not create an open market where we could more efficiently match these storage services with storage users who need places to retain and preserve all of that massive amount of data that is being generated every day. And one of the things that's really awesome about markets is that, especially when we think about markets for marketplaces for underutilized assets, it allows people to differentiate on a number of different dimensions that previously may not have been available to them. So instead of having this option to choose between Azure, Google Cloud, and AWS, and it's really just in a lot of ways like very similar services, maybe. I'm not disparaging that at all, or it's just a very general statement. But you can imagine like there maybe aren't as many dimensions of differentiation or as many options for sure. But you could imagine a world in which there are a number of companies that are competing against many more dimensions, and they're within each dimension of comparison, there are just many, many, many more options. So you could have people, with vastly different prices, storage offerings in very, very different parts of the world, all sorts of other features that you might imagine, like storage providers who are providing GDPR compliance or HIPAA compliance, or some other sort of compliance with like local regulations and laws. And all of these sorts of differentiation, sources of differentiation can be enabled in a marketplace in a way that we don't, doesn't really exist in the world today. But in order to do this, to be, like a good storage provider, it's a bit of a typo here, but to be a good storage provider in 2020, it's kind of difficult if you were to just sort of set up a data center on your own and have to be responsible for not only managing the actual technical infrastructure, the uptime of your operations and everything, but also, getting your own customers. So having some sort of sales effort, having a landing page and some sort of like marketing effort to the world as well, supporting your customers directly, expanding to the growth dimension of expanding to multiple regions globally. And that's just a difficult thing that also doesn't allow, again, for, it requires businesses to have that full stack of both the business backend, this technical backend, and the business front end in one company. And maybe it doesn't need to be that way. Maybe it's possible that people can really specialize and optimize in being amazing storage providers and have the business front end sort of taken care of by the marketplace itself. And so I think really this, this set of conditions makes it possible for decentralized storage networks to exist that kind of solve some of these inefficiencies in the way that we think about storage today with kind of like the dominant model, and really can create lots of opportunities for people to participate in providing these useful services in the world, whether it's smaller individuals or large data centers that are willing to participate in these types of decentralized storage networks. This is a very incomplete list, but some of these names you may have heard of already, and this is the DWeb meetup, so I'm sure many folks are familiar with a lot of these projects. And I think all of these projects do have in common that they really do want to, create, this is the mission of Filecoin, but I think it's true for a lot of the other projects in this space as well, is to create what is a decentralized, efficient, so like market efficient and robust, reliable, like has SLAs to compete with some of the centralized cloud providers foundations, so that we really can create this decentralized storage infrastructure to store all of humanity's information going forward. And so at a high level, how do these networks work? So they all look a little bit different. Some of these storage networks like IPFS, for example, don't really have a blockchain component, and there isn't like a native notion of payment sort of embedded in those sorts of networks. The style that I will talk about is as a network like Filecoin, where there is this notion of payments kind of embedded in the model. And a lot of the networks that use a blockchain kind of have a similar structure to something like this. So you really can think of this as a marketplace. I think that's the most accurate and also simplest way to think of these types of storage networks, where on one hand you have the demand side, and those are storage clients who have data that they want to store somewhere. And on the other side, we call them miners in the Filecoin network, but other networks call them different things. But these are really the storage suppliers or the providers, and they have this spare capacity, whether it's eventually, like one day on Filecoin, it will be just your spare laptop disk space, but it could also be like data centers or hard drives that people have bought specifically to participate in this sort of marketplace. But whatever it is, there is a group of people who have storage capacity to contribute to the network. And then there's a set of protocols that lives in between these two sides of the marketplace. Here it's depicted with a person, which I think, is maps to sort of like a bit of the model of just the world today, like other sorts of marketplaces. But obviously in a decentralized storage network, there isn't a person intermediating these transactions at all. It's purely software and is self-managing. So those are kind of like the three major components of most decentralized storage networks. And the network, which is the set of decentralized storage protocols, acts as this intermediary between the two sides of the marketplace. And in most cases, the way this will look is that a client will decide that they want to store their data with a particular miner. So again, they may have chosen on a number of different factors like price and geographic region and how much available space the miner has and all of these things. Once they'll make the choice of who they want to be storing their data with, they will kind of send their data and also lock up some amount of money in the network protocols. And the network will send this data to the storage providers in order to begin storing it as the client wants. And over time, the protocols will ask the storage providers to submit cryptographic proofs to show that they are continuing to store that data that the client sent them at the start of this sort of storage contract. And that's kind of like a really important feature of what makes these whole systems decentralized. You need some way without having a person or some sort of like check to go and actually see on the storage providers physical devices whether this data still exists. There needs to be some way to like have this guarantee for the client and for everyone in the network to be able to trust that this is actually doing this decentralized network is actually doing the right thing. There needs to be some way to like have that confidence, and that's where the cryptographic proofs come in. And this, in Filecoin, we call these proofs of space-time. And they're sort of, there are challenges that are sent to the storage providers every 24 hours in order to show that they are actually storing this data correctly. And if they are, then they get paid in whatever the currency of the network is. And so really in each of the networks kind of treats these, has obviously it's like nuances and differences, but I think the two key mechanisms that enable decentralized storage networks to work are the economic incentives and the whatever cryptographic mechanisms are in place. So in the case of Filecoin, we definitely use both of those levers, if you will, in order to provide pretty strong guarantees that when a storage provider has accepted a storage contract, a client can sort of like go away and not have to worry about whether or not their data is there for the long term. And they should be able to get it back at any point during the storage contract if they want to use it for whatever reason. So I think some of the things that are really, really interesting about decentralized storage networks, I think there are like three major categories. The first is just this idea of being able to leverage market efficiencies. I think with the way that the storage markets work today, it's extremely inefficient. And this is for a number of different reasons. It's because of what I mentioned before about, having to have these businesses, which are maybe like really strong infrastructure providers, also have to worry about like sales and marketing, which is really just not, necessarily a great use of resources or energy for the people who really want to be focused on just providing very reliable storage. It's also because there is so much storage capacity that it sits idle every day and unused in the world. And so the fact that, these things exist and we can put these underutilized and sort of like inefficiently utilized assets in a marketplace enables some like very interesting things. So it enables this more just greater differentiation and which allows for like better matching between the people who are looking to hire a service and the people who are providing that service. It's the same thing as if you think about with Airbnb, it's just like if you were to just look at the market of hotels that exists, maybe they seem like very similar in the level of options that exist. But now with Airbnb, there's just almost infinite options, and they can be differentiated in so many different ways. So we're kind of trying to enable the same thing here with decentralized storage networks as well, these like very granularly differentiated storage services. The other cool thing about markets is that it enables really efficient matching between willingness to pay on the client side and willingness to sell on the supplier side. So it's just, like a basic thing, but we're kind of trying to leverage that in the case of decentralized storage marketplaces or networks as well. And as I mentioned before, it's just reduces some of the inefficiency that exists with the storage assets by making use of the underutilized assets. The other really amazing thing about decentralized storage networks, and this is a feature that I am particularly excited by and inspired by, because I think it enables use cases that just can't really exist with any other sort of system, is this idea of publicly verifiable storage. And what I mean by that is, when in the earlier slides when I was sort of talking about this idea that the network protocols can challenge storage providers to periodically prove that they are storing data correctly, what they're actually doing is they're submitting these cryptographic proofs to a blockchain. And anyone in the world can look at the proofs that exist on the blockchain and get that guarantee. And it doesn't even have to be the original storage client, but anyone in the world could look at that and get this guarantee, basically, that whatever the file was that was originally being stored was actually stored for whatever like the duration was. At some point, the proofs will end because the storage contract will end, but it was proved for that period. It was stored for that period of time. And some of the use cases that I think this really enables are, I like to think of this one, it's kind of like a straw man example, but just imagine, for example, if someone were to want to post, had an original video of like some sort of artwork or something that they like created, some film or something like that, they could store this data to a network like Filecoin or another network that has this sort of like verifiable storage feature. And they would essentially, because of this, like these storage proofs, they would have this publicly verifiable record that exists in a public ledger, like a blockchain, that is timestamped essentially, that says that, okay, like in this particular block, which is correlated with like a real world time, this particular video, which has a content hash, was stored on this network. And like, that is a thing that no one could really dispute. And coupled with other technologies that like maybe give you some additional guarantee about the actual like timestamping of the original file and things like that, you could actually increase those guarantees very strongly so that you really do know that when something has been stored on this network, there's maybe some metadata in the file as well that says like when the file was actually created. And you really can have this audit trail of when data was created, when it was stored, and then sort of like the lifetime of that storage on the network for as long as it is there. I think this is really amazing because it's basically a core primitive to be able to fight certain types of misinformation. You could imagine someone later down the road pirating that content and maybe trying to store the same thing without like changing the metadata. You could compare like the the content hashes of these two files, say that they were the same, but see that they were the same, but then see that like one file was stored much earlier in the history of the chain. And that would maybe give you some confidence to say, well, the person who's trying to store this later is pirating this content or something like that. So I think like that's a really amazing feature. And it's very difficult to do this with non-decentralized or centralized storage solutions. And I think will enable a lot of really wonderful things for the world. And then the third area here is just this idea of economic incentives, which I think the entire crypto space has shown that economic incentives can be insanely powerful to motivate certain types of behavior. And so I think that's just one thing that is very interesting and can be leveraged in a lot of different ways in these types of networks to do things that like just otherwise totally would not make sense. Like there's just no way you could motivate so many people to cooperate together to do a thing like this without these sorts of economic incentives, but they all kind of like work out, and very complicated, very interesting, but it enables these types of systems to work, which I think is pretty awesome, just intellectually. So yeah. Okay, so how, when we think about building with decentralized storage, what are some of the core considerations to keep in mind. And I'll also talk a little bit about some specific examples that I, at least in my work with Filecoin, have seen over the last several months. So this is just kind of, I think just one old sort of, I guess, stack diagram for what the Web3 space looks like. This is kind of how I think about what the Web3 application stack looks like, where there's sort of, and this is true for, I think, most applications, but there are, in some of the specific examples here, some Web3 options. But most of the applications will have some sort of storage component. On top of the actual data storage, there's some sort of like database or index. Probably the application has some sort of compute involved. There's a front end, maybe there's a naming component if it's like a website or something like that. And so at each of these layers, there really are just so many different options. And obviously not all of these are like Web3, I guess, options, but there really just are so many new solutions that are trying to fit at each of the layers that are necessary in order to build a really solid application. One of the things that we at Protocol Labs have been building for like the last 9 months, I think it is now, is an application called Slate. And I like this one because it kind of touches all of those components of the Web3 application stack. But Slate was really our attempt to kind of dog food the technology that we at Protocol Labs were building. So IPFS and Filecoin specifically, and also some of the second layer dev tooling and other like database and other solutions that were being built by a company in the ecosystem, which many people probably know, which is Textile. And the idea here was really, there's some screenshots here of kind of what the application looks like, but it's, we were attempting to build just like a really beautiful kind of best in class Web3 product. And it looks and feels just like any other application, but under the hood, everything is, it's definitely all of the data is being backed to a decentralized, backed up to a decentralized storage network. And also the primary storage layer is a decentralized storage network. It has collaboration and sharing features. It also had a launch on Product Hunt and now has more than, like 5,000 signups and things like that. So it was really just like, what if we wanted to build just a beautiful application that is like fun and engaging and feels like a Web 2 app, but it's really a Web 3 app, what would that look like? And so that's kind of what Slate was. And everything's open source. And so if you're interested in building kind of like consumer facing applications on like decentralized storage stack, I would really take a look at Slate. And you can also play around with it at slate.host. It's definitely cool. I think now it also supports games. So you could like upload Unity games and stuff to Slate, which is pretty awesome. Another application here is that I've seen recently, which is also pretty awesome, is called Space. And this is really intending to be kind of an alternative to Dropbox, but again, built on like just a Web3 stack end to end. I believe that this application is also fully open source. It's built by a company called Fleek. Fleek is probably best known for their IPFS website hosting product, but they are venturing into a number of really interesting directions, including Space. And Space is both the front end, which is the screenshot here, but they also have a daemon which integrates IPFS, Filecoin, and a number of other, some decentralized identity protocols, a bunch of other Web3 protocols basically. And really their intention is like, that's all you need. If you want to build a Web3 app, user-oriented app, like that's really all you would need in order to have all the components that are necessary to have like a fully featured application. We've seen a lot of really interesting decentralized video applications as well. And also the start of some games. So yeah, some fun stuff here. One collaboration, which is, I think one of like the more important collaborations that I've gotten the fortune to be involved with, is with an organization called the Shoah Foundation. And the Shoah Foundation is, it's a nonprofit organization that exists to, basically, I think, their mission is to try to connect the various peoples of the world together through maintaining this very rich visual history, like a video archive of many of the historical moments of just our human past. So specifically, they have a video history archive, which includes testimony from more than 55,000 survivors of genocides from around the world. This includes many Holocaust survivors, many survivors of the wars in Syria and the genocides in Sudan and other places in the world. So it's just this like incredibly important data set that we want to preserve for all of humanity, right? Like this data, we want it to exist and for it to be around as long as possible. It amounts to something like 9 petabytes in, more than 9 petabytes of recordings. And we've been working with them specifically to get their data stored on the Filecoin network because they want to be able to make use of this verifiable storage feature that I was talking about before, where you know, they associate some metadata to kind of certify the authenticity of the actual original video footage. And then they are storing that data on the Filecoin blockchain, getting the proofs back out of it, and using this as kind of like a timestamped proof, not like a cryptographic proof, but timestamp, just general proof that like this data was stored, and you know, like there's a publicly verifiable record of that, and then coupled with the metadata they're actually bundling with the video, it provides this kind of like again, just this protection against people who might want to deny that these types of atrocities actually occurred. So it's just this like incredibly important use case, and I think that's one of the ways in which we've seen this verifiable storage feature be really valuable. Another one is just, you know, again, I mentioned before that there is just so much data that we're generating every day as a society. It's just the numbers are just truly mind-blowing and really staggering. And, you know, we've been working with a number of organizations to archive as much of these extremely valuable data sets that we know of. And this is, again, an incomplete list. Over the last several months, we've now added like, you know, several dozen additional data sets to this. But we've been archiving these through a project called Filecoin Discover. And again, this is, you know, the scale of this sort of project, we're looking to upload more than 100 petabytes of these types of cultural and scientific data sets to the Filecoin network, and then make them retrievable through an online portal. And yeah, just, you know, wanting to reiterate again, there's just all sorts of like really interesting things that are being done with these types of decentralized storage networks today, whether it's like really beautiful consumer facing applications to just like incredibly emotionally compelling and also just culturally and historically relevant data sets, to scientific data sets, to like massive, you know, of massive scale. And there really is a lot. So it's just starting to build the legitimacy of what these types of networks can do. They're not really toys or like something to be kind of dismissed, I think, anymore. They can start to serve like some very interesting real world use cases. All right, so what are some of the things that you may consider building as you're getting started kind of in the decentralized storage space? I know a lot of the people here are probably have been thinking about some of these things already for a while, but hopefully there's some new nuggets of inspiration in here. So I think from like a storage perspective, there are some very interesting applications that I think have yet to be fully like, you know, people just haven't, these ideas have been around, some of these ideas have been around for a while, but people haven't really like explored what it could mean to do these for real. If you wanted to build like real businesses on the basis of this, I think now decentralized storage networks are getting to a place where you can actually do these and build real products and real businesses on these networks. So some of these ideas are just, I don't know what it is, but just more applications that make use of this really compelling verifiable storage feature to like fight misinformation. I participated in a panel a few weeks ago with the Decrypt media team, and we were sort of talking about how like Web3 can be used to support, like what's the intersection between Web3 and journalism. So I think this like idea of verifiable storage and misinformation and journalism, there's like a lot there that has not yet been fully explored. And I think the infrastructure exists now for people to actually start looking into this and thinking like, what do these next generation media sites look like, as one example. Another example is this idea of data marketplaces. And you know, the high level idea behind a data marketplace is just individuals in the world or organizations in the world have some data that someone else in the world cares about and would probably be willing to pay for. Really, it's just, you know, wanting to connect the people who own this data with the people who are willing to sell for access to it. I've seen this like in the context a lot of especially like when we talk about within Web3 of personal data, where, you know, today, like our search results and what we're doing on Facebook and Instagram and Twitter and whatever, we as people, like our activities are being used to fuel the profit engines of these like very large institutions, and we're not getting anything back, right? Like those institutions are capturing all of the value from the work that we're doing, sort of like using the tools that they're providing. And so a lot of people care about, you know, privacy and user ownership over data and things like that, have thought about how data marketplaces could be used to make it so that, you know, we have complete control over the data that we're storing. It's not stored in, like my Instagram photos are not stored in a data center that like Facebook controls. Maybe I store my Instagram photos on a decentralized storage network. And then when Instagram wants to leverage my data for advertising purposes or whatever it is, they could maybe pay me a small fee if I'm willing to access some of my photographs and then, you know, do whatever analysis they want and then profit off of that with advertisers. So I think there's like something, again, like the infrastructure, the storage infrastructure for this hasn't existed for a long time, but it does exist now. And I think these ideas are very interesting and can be explored further for sure. So just like really quickly, you know, I think right now we have a lot of really interesting options for smart contract platforms, interesting decentralized storage platforms, building the bridges between these two. So much opportunity there. They don't exist yet and they need to be built. Also building like smart contracts that compute over very large data sets is just another version of a bridge, but more application specific. So I think that is also very interesting. And just in general, like storing all sorts of really cool data like game assets and virtual worlds and packages and containers and all that good stuff. Just actually storing and preserving these data sets that you think are interesting. And then I'll maybe just sort of stop after this slide because I've been going for a while, but there's a huge amount of just layer 2 protocols and developer tools and utilities and just all sorts of like really valuable things which are needed in order to take these like, you know, these decentralized storage networks, they work. But it really is like in interacting with one of these networks, if you know, folks here have tried, it's pretty painful. It's like interacting directly with like a file system through the command line, which is really not the experience that most people want to have when they're just thinking about storage today, right? Developers and consumers alike. So there really are just a huge batch of tools that are sort of needed to make these networks much more usable for developers and end consumers. A lot of these are, you know, a lot of people are working on various pieces of this, but again, there's just, you know, the ones that I'm listing here, there's, you know, very, very few people are sort of working on some of these ideas, and there is just no shortage of opportunity to just like build the best one or something. You know, it's still like we're in the phase of lots of small experiments rather than like people really investing in these, figuring out what is like the actual ideal product flow or the user flow that is really going to make this tool successful and really owning that and just delivering an amazing experience. And if one of you were to do that, I mean, I think there's so much opportunity. So many people would use it. I would love to help support anyone who would be willing to do that with promotion, potentially grants and things like that. So there's some ideas here for like, what are we sort of seeing as that needs to be built on top of some of these decentralized storage networks, but there are a lot more ideas out there. And I'd definitely be happy to chat with anyone who wants to talk about these things. So yeah, I have a few more slides, but I think I'll maybe just stop here and we can chat openly about any questions or ideas that folks may have.
Thank you, Pooja. So I think anyone who wants to ask a question, maybe just go ahead. I know I have a bunch of questions too. I'm going to hold because, you know, attendee gets privileges. So yeah, if anybody has anything, please go ahead.
Kelsey, did you want me to read these? I think there's one from Kevin here in the chat.
Oh yeah, sure. Or I can read Kevin's and then you can respond. It'll feel more natural.
Sure.
So Kevin asks, in the Filecoin architecture, can the storage provider review the content they would be paid to store?
That's a really good question. So sort of. I mean, so the way that the protocol works is kind of the user will propose a deal to the storage provider, and the provider can choose to accept or reject the deal. But the actual like data transfer between the client and the provider doesn't begin until that deal has actually been accepted. If it is, you know, so natively through the protocol, I think the simple answer is no. If the data is also stored on another network, like IPFS, for example, the content hash will be the same. And so the storage provider could try to retrieve the data from somewhere else just to kind of like review it if they wanted to do a manual check to see if they wanted to accept the deal or not. But in practice, most people don't do that. The way that we do, I'm not sure exactly what the motivation is behind this question, but I have gotten this question a lot before. From the motivation of like, what if someone is storing bad data, right? Like, yeah, I won't give examples. This is like being recorded, but just, I'm sure we can all imagine like bad data that maybe people wouldn't actually want to store. And in that case, Filecoin does have this ability for miners to prevent a retrieval of the data back out from their data stores. And so that way, effectively the data is like just not accessible from the network. And so it's almost as if it hasn't been stored. But the problem is that like the miner can't just, you know, delete the data because that doesn't work with the way that we're trying to do these like publicly verifiable proofs so that the client can have the confidence that data is being correctly stored over time. I don't know if that answers the question. And I'm a little sick, so I'm gonna cough 1 sec.
Can I follow up on that? That's really interesting. I guess, so Filecoin provides a miner side tool that says, okay, I looked at this data and I didn't think it was like acceptable to share out. So they continue to hold it and get paid for it, but it can't be retrieved by the person who put it there.
Yeah, exactly. And there's actually some like interesting non-technical or like non-software bits of this where miners can sort of signal in advance that they are basically not going to, they like are not going to, they don't want to store certain types of data. So they can post like terms of service somewhere that say that. And so essentially like when a client is making a deal with that miner, they're agreeing to the miner's terms of service. And if the client ends up storing something that violates a miner's terms of service, then the miner can choose to like refuse it. But it's that part of like, how do they choose to refuse the retrieval is more programmatic. Basically the terms of service would identify a set of content, lists of content hashes, which the miner would consider to be on sort of their like deny list. And that's something that they're sort of advertising to the world as part of their terms of service that like, hey, if your content hash is on this, one of these lists that I subscribe to, that's like a deny list that I like, you know, of data that I don't want to be serving back, you won't get it back from me if you store it with me. So yeah, but there's that part is kind of interesting because it's like, you know, where these terms of service get advertised on like GitHub and websites and things like that. And it's not actually like native within the protocol. Yeah, exactly. Jim posted a this like filter, which is exactly the one, an example of the thing I'm talking about. Yeah.
Yeah, just for the sake of the recording, that's GitHub/murmuration-labs/bitscreen. Really interesting. We also have a question from Costin who says, who's computing the going rate or rates for byte of storage on IPFS, if such a feature is implemented, planned, or envisioned?
And Costin, do you mean like for IPFS or for Filecoin? I ask because you know, we will have much more native bridges between IPFS and Filecoin one day. Okay, cool. Yeah, so for Filecoin, when you say going, so basically each storage provider sets their own price. So they sort of like compute their own, we call it an ask price. So they compute their own ask price based on the costs involved in running their own operations in most cases. And so that's like a mixture of different inputs. It's their hardware, the labor costs in like maintaining their, you know, mining machines and stuff, Also the costs of transacting on the network. The network has transaction fees just to like post messages on the network. And so all of those costs kind of are inputs into like the miner's cost function. And yeah, thank you, Jim. These are great. Yeah, so Jim is posting a link to philstats.com, which shows sort of like the average ask price for miners on the network, and then storage.codify.network, which has a list of like all of the miners and kind of their asking prices. And then on the IPFS side, so IPFS today doesn't have any notion of payments, but in the future, I'm not sure it's going to be in 2021, but if not, it will be in 2022 or sometime in like the next couple of years for sure. Like these much more native bridges between IPFS and Filecoin, where you can pay, if you are like just an IPFS node, you can pay to retrieve data from the Filecoin network, say if it's stored there. And sort of like vice versa. If you're a Filecoin node, then you can pay to retrieve data if it's on the IPFS network, but like not on the Filecoin network. So, but that is like currently not a feature that has been implemented. There are some issues, I think in the Lotus, I don't know what repo it's in. We created these like a very long time ago, a few years ago, but they have been like envisioned for sure. And we want to enable that as soon as possible. But if you just look up like IPFS Filecoin interop on the Filecoin project, then you'll find some of these issues that talk about some of the initial designs.
I'll ask one of mine.
Go for it.
You can go after. I'll ask one of mine, which is that, so like say I don't really care like that my thing is super well duplicated or you know, nearby. Basically, I just want to be able to say, okay, I want a backend for my web app. I'm throwing it up on something simple like Heroku. Is there any way, or is there a trajectory to just say, hey, can you just make sure it's reliable and that it's not on just one node, and just kind of have it go?
Yeah, totally. Yes. Yeah. So there are like, today there are a few solutions that allow you to do this where you don't like, you maybe specify the parameters you care about. So if you care about a price, say like you don't want to pay more than a certain amount for this backup, then you can specify like those parameters. Maybe you want to filter by geographic region. For some data sets that can be really important. And you can specify like some of these other parameters. And there are tools. One example, it's like probably like much more heavyweight than the sort of thing that it sounds like what you're describing in this use case, but one is called PowerGate, which is built by the Textile team. And that basically, that tool will allow you to specify some of these parameters, and then it'll choose the miners for you. So, you know, that there are some tools like that that allow you to not have to worry about the specifics of like, how do you deal with the actual mechanics of the network. But the space is young, and I think a lot more tools like that are needed that provide some like layers of abstraction between apps and the decentralized storage networks themselves.
Okay, Cameron, you can go.
Yeah, I just had a question. What have been like the main challenges to the network since launch? And seems like one of them is becoming, at least from what I've been seeing, like message throughput rate and gas fees. Can you talk about those issues and what's being done to address them?
Yes, it's a juicy question. So yeah, we launched the network like 2 months ago, and definitely like we basically hit problems of scale immediately after we launched the network. So the network now has like 1.4 exabytes of data on it, of storage capacity on it, which is like, you know, almost two exabytes, which is huge. It's like just an insane amount of data capacity, storage capacity. And we were sort of initially thinking that we would hit like an exabyte within a year after launching the network. So, you know, it was just like very quickly the level of interest in storage mining like very much exceeded even what we thought were very high expectations. And so definitely message throughput was has been like a constant, you know, just like we've been monitoring it. It's been much higher than we thought it would be, and much higher than we hoped it would be for like quite a long time. So that's definitely been, I think, one of the major challenges. And the other thing is just, you know, the realities of data transfer across the world when both of the nodes that are trying to participate in this like connection may have, you know, in this data transfer process may have sort of like spotty connections. Like that's what you need to happen on this network in order for storage deals to actually work. But it's just kind of like one of the things about distributed systems that there isn't really a way to, like, if all you really need to do as a client is to send your data to one miner, there isn't like, you know, another fail safe, like sending it to another miner is not going to solve that problem for you. So really that just like one thing actually has to work really well. And so that's where we get into some of the realities of just like the internet and networks and like some of the instabilities in networks and just causing problems for some of like the core functions that like Filecoin as a storage network needs to be able to solve. So I think like those have just, you know, affected different parts of the market differently. I think the message fees, we've done a lot of things. Like, you know, we've created, there have been like subsidies that we've created and all sorts of like miner support programs. We also actually very recently, like this week, announced a FIP, basically like just a Filecoin improvement proposal that takes the, so every time some portion of every message's transaction fees on the network gets burnt. And we basically created an upgrade, we released an upgrade that will, instead of like burning some portion of the transaction fees for a particular type of message, which is like the window post message, if those of you are familiar, we decided to say that like those burnt funds wouldn't actually get burnt. And so that's actually like significant reduction in the cost of messages for that one type of network positive message. But yeah, I mean, like chain scalability is a huge problem. And like the actual longer term solution to that is going to take a long time. And so that's another thing. If people are specifically interested in like protocol design and things like that, that is a huge challenge and like for the team and a huge priority for the team. And we'd love to definitely work with people on that because that's a big one and it's not fully resolved today. And then on the data transfer side, a lot of that has, you know, come down to basically just getting more information about like what is actually broken. And, you know, so that's involved, again, just like more dedicated testing with a set of clients, like who are not us, but, you know, people who are actually trying to store data, who have like these weird, you know, people structure their data in weird ways and different ways. So like having this diversity of kind of like client storage use cases and then different miners and like really just trying to get information from both sides to begin really debugging actually like what's going on there. And we're still in like the early solution design space, but like how could we do this? One idea that has come up in the past before network launch was this idea of repair miners, where you could basically send your data to a repair miner who's sort of an interface to the storage mining layer. And and again, it's kind of like a, you know, one-to-one connection that sort of needs to work, that like one data transfer needs to happen. But you could like, you know, repair miners could be incentivized to be like folks who have like hyper reliable connections or things like that. And so you just expect very high SLA from them. And then they manage all of the data transfers to, like, you could maybe select, oh, I want 3 redundant copies, and then they would find the miners, start sending the data. If the data transfer failed, they would like maybe find another miner, things like that. And so it's kind of just like this layer of this interface that would preserve a better client experience. But, you know, to do that in like a decentralized way is still pretty tricky, and like a verifiable way is still pretty tricky. So we're still working through the solution space there, but in the debugging stage right now.
I saw Juan mentioned, I think it was a week or two ago in like a storage summit, that they were potentially looking at more short-term solutions like sharding to get more messages on there. Are you looking at that as a short-term solution? Will you work on a faster proof, or?
I think like the reality is that even some of those types of solutions are not actually, like, they just require a lot of work to figure out like the specifics of how that would work and to actually implement it. And, you know, so I think right now we're like basically all of the solutions are kind of on the table. I think that's definitely one of them. But right now, because we published this like very short-term fix, which we will probably revert at some point, but for now, like that's kind of our immediate fix for some of these issues we were seeing. And then, yeah, and then like some of these other things it's a big solution space. So we'll have to like spend some more time like evaluating different options. But yeah.
Thanks.
Yeah.
So I'm actually going to jump in. We're so close to the end of the hour, and I want to make sure that we end the event on time to make sure we don't keep anyone past when they plan to be here. I'm seeing some really good questions continuing to come up, but I did want to give a little bit of space to, first of all, community minutes, if anyone has any, and I can start with my very, very short plug, which is if anyone wants to come speak, we don't have anyone lined up for January yet. So if you want to come do a half-hour presentation and then Q&A, please tweet. We're at DWeb Seattle. Yeah, is there anyone else who, well, so yeah, I guess also since it's 8 now, I'm wondering, Pooja, is there anywhere where people can follow up with you?
Yeah, definitely. If folks aren't already in the Filecoin Slack workspace, it's a super active community there, and that's the best way to follow like what's going on in terms of updates with the project, and also to like chat with various members of the community, including myself. So yeah, if folks want to ever follow up about anything, you can join the Filecoin Slack space. I'll just post the link here, but it's filecoin.io/Slack. And I'm just my first name, Pooja, on there. So you can always DM me, and happy to chat.
I'm actually going to have to go because I have the next thing to do. But I can leave this room open for anyone who wants to continue to talk. And I'm super sorry I didn't save good time for community minutes. I didn't have any signups. So, you know, for next time, if somebody wants to make sure there's time to present, that'll help. But I'm going to log off, and you all can stick around as long or as short as you'd like. Thank you so much, Pooja.
Hey, thanks a lot.
Thank you, Pooja.
I want to say hi to Kevin. Hey, Kevin. I know Kevin.
John,
from 10
yeah,
years
so
ago at LimeWire.
it has been, John and I worked at LimeWire. We're pioneers of decentralization,
Yeah,
and we
saw
haven't
your
seen
name.
each other.
I didn't figure out that was you because I think of this as a Seattle group, and I knew you in New York 10 years ago. I'm like, there's another Kevin Fabor.
What's geography in these unprecedented times? I say, I've been going, yeah, yeah, exactly.
Sorry, you guys get to watch all this, but
Sorry, right.
Great to see you.
Absolutely. No, we should catch up.
Yeah, I'll private message you my email and we can connect. But I would just say, sort of for the interest of the group, I think of this as what I thought LimeWire might be able to do 10 years ago, just by having a decentralized peer-to-peer communication network. I kind of thought we would go in that direction, and we didn't. So I'm still, all the things I wanted to do back then, I think this technology can do now.
I agree completely. Yeah, and it's amazing with the Web3 stack.
Really.
Yeah. And it's amazing
I'll
with
send you my
Web2.
private email. We don't have to bore these people.
Sure.
But,
Yeah.
It's really great to see you.
Yes,
it's
you
really
too.
Great to see you. I'll send it right now. Yeah, cool.
Awesome. Are most folks here working on projects in kind of the DWeb space, or curious? Jim is. Okay. I guess not yet, but
Silence.
I'm sure one day, yes. One day very soon.
All right, Pooja, did you have time to answer that last question in there? It looks like it's got a few points.
Yeah, for sure. Okay, so Avinash asked, first question, is something being done to tackle the storage power imbalance geographically? Miners in Southeast Asia seem to have way more power than others. Yeah, it's a really good question. Well, so first thing, yeah, I mean, because this question is specifically scoped to the geographic distribution, you may already be aware, but like one thing that's kind of interesting about the Filecoin mining community is that it's very distributed just from like a number of, miners perspective. Like there aren't one or two miners or three miners that like own the top 50% of the network. It's very distributed. And so like that is kind of just a really important thing for us, especially in the early days of the network, to make sure that it's very secure. So but yeah, from a geographic distribution perspective, there are a couple of things that we're sort of doing here. There some like programs that we are working on, but like sort of haven't been announced yet, but essentially look like mining accelerators in different geographic regions. We also like today, sorry, not today, yesterday or the day before announced a small fellowship program for miners who were in just like geographically distributed. Essentially, some of them may come from like the greater China region, but most of them are not. And sort of like working with these smaller miners to like provide some financial support, learning, like what their experience is like just understanding how the costs differ in like different geographies and stuff like that. That program is called the Miner X Fellowship Program, but really just like trying to understand a little bit more like what does the situation look like on the ground right now, and what are some of the things we can do to help like stimulate those areas. I think it's still like pretty early days for the network, and so I do think this is going to more naturally shift over time. Like it's just been like 2 months, but yeah, that's one of the things. I mean, of course, there's also like a lot of the other stuff we're doing that's more like marketing related and just building stronger communities and presence in general in other regions in the world. One of the things that's kind of interesting about Filecoin is that just pre-launch there was already so much interest from like Southeast Asia, and definitely some interest from like other regions too, but like the level of the magnitude of interest was like so much higher, and people were just ready to take the leap and plunge in so much earlier in kind of that geographic region. And so we think like building stronger communities and just presence in like these other regions will be like something that pulls more miners into the network as well. And there's a question about, in the developer tool slide, you mentioned decentralized identity as an area of opportunity. Can you talk more about this? Yeah, just a very little bit, because honestly, I'm not super, I'm not an expert in this area at all, but I think it's really just like this recognition that what I think we want these applications to, it's just like I think a core piece of when we think about like decentralized apps, we obviously want like user management systems that can rival the power and flexibility of like Web 2 user management systems. But that kind of conflicts with some of these like, ideas of user ownership of data and, sorry, I'm blanking now, but yeah, like decentralized storage and things like this. And so it's like a critical piece, I think, of when we think of this like end-to-end app story. It's a critical component that needs to exist. There are a lot of folks who I think are interested in decentralized identity, but I don't think there have been any solutions that have really worked in the, like they haven't really worked yet as products and haven't seen significant adoption. So I think that there's still a lot of opportunity there. And I think it's pretty clear that like once something does work there, it'll just like be used by everyone, but like we just need to I don't like the phrase cross the chasm, but a little bit cross the chasm with that to get people to start using like an actually workable solution that meets all the requirements. Okay, and then the last question here is, in the medium to long term, do you expect to be supply constrained or demand constrained in terms of data storage? Interesting question. I think like in the medium to long, I think it depends on like what time frame we're talking about. Medium term, I think of as 5 years. And in 5-ish years, I think we will still be, like we'll still see significant supply on the network. I think like much more than like the sort of demand that we may expect to see. But I don't know, I guess like we would sort of expect, right, in the long term that there would be some sort of equilibrium where it's kind of like the more people are willing to pay for storage, the more that incentivizes new people to like enter and be miners and so on. So I don't know, it's like hard to think about in the long term, which one is going to be kind of like applying more of the pressure on the network. I don't know if you had like a specific, if you want to expand on that at all, but yeah. That'd be my initial take.
Could you talk a little bit about the Filecoin Plus program and where it's currently at, if a developer can use it right now, and I guess also how you expect it to affect like geographic distribution, like earlier in the question.
Oh yeah. Yeah, you're super plugged in, Cameron. That's awesome. Yeah, Filecoin Plus. So basically, Filecoin Plus, it's a mechanism that kind of the idea for it was originated like earlier this year as a economic incentive for miners to accept real, to start storing like real data and accept real data. And basically the problem was like, how do you, if you just straight up, like just using the decentralized storage, the software protocols alone, if you provide people with like some sort of economic multiplier or something for storing real data, how do you know what they're storing is actually like real data, right? They could totally be storing garbage. It would look indistinguishable from real data on the actual chain. They could be storing their own, like their own garbage. And so this mechanism was, includes like an off-chain sort of just like, you know, processy governance component, which is basically certifying people who submit an application to say, hey, like I'm a real person or organization who has real data and I want to store it on the Filecoin network. And those people we consider verified clients. And they're allocated some amount of, they're allocated what's called data cap, which is like, you know, say I'm applying to store like my, if I'm an application developer and I'm applying to store my users' photos on the network, and I can apply for like 10 gigabytes of data cap or something like that. And if I'm sort of accepted, I will basically have this allocation that allows me to perform what's called a verified deal. And if a miner accepts my verified deal, then, and let's say I just decide to use all of that data cap all in one deal. So it's like 10 gigabytes of this like verified deals, verified data. Then when the miner accepts that deal, that 10 gigabytes of data will actually count for 100 gigabytes in the consensus process. And so for that particular chunk of the miner storage, like the 10 gigabytes of storage that they committed to the network, they're actually getting like 10x the likelihood of sort of like winning block rewards. So it's a really powerful economic incentive for miners to accept real data on the network. And we're calling that program Filecoin Plus. It was in beta for like the last several months, and just like this week, a bunch of stuff is kind of converging for near the end of the year. But we basically announced a number of entities in the ecosystem who are called notaries, and they are basically the people who can sign off on these verified clients and say like, yes, okay, you're actually like a legitimate person or application, and here's how much data cap you get to be used for these verified deals. And yeah, this like all of this stuff is kind of live. It's very early, so we don't have a huge amount of documentation about it. But we actually are working on like a guide that should be ready by the end of the week. So it's just going to be like a Google Doc. But if people want to play around with it over the break, you totally can. I can find the link and maybe send it to you, Cameron, or to Kelsey or whomever, and maybe you can share it with the group. But yeah, that is something that does work today.
Awesome, thank you. Yeah, if you send that over, I can get it out to everyone.
Cool.
Does anyone else have any questions or comments or anything? All right. Well, thanks for staying a little late with us and answering those questions. Sorry they weren't all softballs. But yeah, thanks everyone for attending. This has been recorded, and we'll get it up on the YouTube channel if anyone wants to reference it. Cool. All right. Well, have a great night, everyone.
Thank you all.
Thank you,
Nice to meet
Pooja.
you. Thanks.
Appreciate it.
Bye.
Thank you. Take care.